Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back working on the New Haven metal planer restoration, and off camera getting ready for this. I've got two more shafts that need to go up underneath the bottom that basically takes the power from the pulleys and reduces it down to a big bull gear that makes the table go back and forth across the top. And like I said, I've got two more of those to put on. I've already got one of the shafts cleaned up, ready to install. It was just a matter of cleaning it up. Everything was good on it. The second shaft, this is the main drive shaft that basically the pulleys come from the counter shaft down to this and drive the whole machine. You see the big pulleys back here. I got 4 pulleys. 2 of them are tight pulleys, 2 of them are loose pulleys. One set is for the forward speed and one set is for the reverse speed. And we got to get all this put back together. Now, in the process of getting things cleaned up and ready, I pretty much came to the conclusion that one of my shafts was pretty much beyond repair and was just needed to replace it. So that's one of the tasks that we're going to be working on today, is getting that new shaft put together so that we can get all this put back together and on the machine. Let me show you this old shaft and why we are replacing it. So here's our original shaft back here, and you can see we got a couple of keyways. There's actually 3 keys on here. These 2 drive tight pulleys that whenever the belt's engaged on them, it's spinning them. On the ends, it has a section where a pulley is just literally rotating on there. It's what's called a loose pulley. You can slide a belt from the loose pulley to the tight pulley to engage it and back off the disengage. This center keyway here is for a gear to slide back on to engage and disengage, and then we've got another tight pulley down here. Now, the original shaft was 1.5 inches in diameter. It's actually about 2 or 3 thousandths undersized in an area that is unworn. This area is pretty much unworn. What's interesting is that when you get down here to where the tight pulley's at, you can see it was machined right up there. At first I thought that was wear, but then I realized this is a tight pulley. This is a keyed pulley, so it's not spinning on there. That's actually the nominal size of the shaft, and it's measuring about 1 inch, 455 thou, which is pretty much in line with the bores that are in the pulleys after I went and did some measuring on them. So we're going to have to machine this down a little bit undersized. The center part here I think is going to be okay at 1.5 inches. My parts slide on that. I may buzz a thou or 2 off just to get it back down to what the original here is. But anyway, we got some machining to do on the shaft, but let me show you really the big reason why I want to replace this. Let me get this up and I'll move you down here where you can see it. When I took all this off, there's a bearing housing. In fact, this is bearing housing right here that this shaft fits up in. There's a cap that goes on top of that. Babbitt bearings basically here. But this shaft, if you look right through here, has severe pitting right along the bottom. And what happened is some moisture got down in here. There's a groove in the bottom of this pulley, and that's an oil groove. And what had happened is it looks like that got water in it, and we had a matching area here on the shaft where that water just caused it to decay away, and we've got some severe pitting in there. If I put this shaft back on there with that rough spot in there, it's just going to tear this bearing up. So, yeah, I could spray weld it and machine it back down. I'm just opting to go with a new shaft. So anyway, that's kind of where we're at. I need to cut this shaft to length. I need to put centers in the end. Like I said, we need to turn down the diameters from on the ends down here, maybe fuzz a little bit off in here where the bearings are going to go, just to get them where they fit these bearings a little bit better. Like I said, the nominal size of the shaft is about 2 or 3 thousandths smaller than the shaft I have here. And I think once we do that, we can get this shaft put back together with all the components on it and get it back on the machine. So let's get over to the lathe and we'll get this set up and hopefully start making some chips and getting this thing ready to go. We're over on our Monarch Model K 16-inch lathe. I have my shaft in here. We've got a steady rest set up where it is running on center. I just inked up the center there with a magic marker, took my little center finding device, put a couple of lines in there, found the center, and line that up with the live center here on the end. So that tells me I've got it on center where it needs to be. I'm gonna push the tailstock just out of the way right now, and we'll come in here face that off. I'm actually going to crown it a little bit, and we'll put a center drill in there to drill a hole so we can put a live center to support that end. Now let's come in here and just face that off first. And do that until it cleans all the way up. Pretty close there. A little bit farther in. All right, I've got my compound set to about a 20-degree angle going in this direction. I'm going to come in now and kind of just put a little bit of a crown on that. I'm trying to copy what the original was. Got a little chatter. Pull it back this way. I think it'll cut a little bit better. On the original shaft, this is just kind of curved, and what I've done here is just kind of put a straight line in. I'm going to take a file now, and I'm just going to kind of blend these ends out to kind of get that curved look on there. Try to mimic the original. Just kind of rolling this file. Until I get it like I want. Take a file card there and clean it up when it stops cutting. And that actually looks pretty good there. It's just kind of rolled over. Got a center drill in here. We're going to come in and put a center hole in the end. That'll be for that live center to support the end from. And that should be good. We're ready to start turning this end down. This is where the pulleys are going to go up on. Right now we're at 1.5 inches. I mic the inside bores of those pulleys. This shaft needs to be about 1 inch 460 thousandths in diameter, which means I've got about 40 thou I need to take off. And it needs to go in 7 3/4 inches, which I've got a line marked down there on that mark. So let's see how this cutter's going to cut. We'll come in here, touch off, and we'll take about 20 thou total, which is really about 10 thou per side off to start with, and we'll go from there. So we took about 20 thou off the first pass, and I'm taking another 15 or so off this pass, and I want to just have a real light pass to go back and clean it up with in the end. Like I've had trouble with before on these long shafts, even with the steady rest in here, I'm getting a little bit of chatter in my finish, so I'm taking fairly light cuts, fairly slow feeds, and just trying to work through it. And we'll finish up with a real light pass on the final pass that will hopefully give us a nice finish. And then polish it out. So I think we're going to be fine. We'll get through this pass, take another measurement, and take off that last few thou to clean it up. I'm on the final pass now, and just like we dialed it in, it's a 5 thousandths cut. So I took 20 thou, 15, and then this last one 5. I probably could have done 2 20s and been fine, but I'm just being kind of picky about that final finish and taking my time and getting good finishes on this. These are going to be bearing surfaces, at least part of it is. So I want to have it nice and smooth. We should be right on the money now, which is 460. 460. And I'm a little bit crooked there with that thing behind me, but yeah, it's right under 460. All right, we're good on that. So on to the next thing. So next step here is the end we turn is just down below us here. There's an area in here where I've got a bearing, an actual Babbitt bearing, as well as an area that a gear slides on. The nominal size of the piece of metal that was original to this machine is about 5/1000ths under an inch and a half, 4-inch, 9.95 is the measurement. This is measuring right on inch and a half. So just to make sure nothing's going to bind up, I've actually tried to do some test fitting with this shaft like it is. It's just a little bit too tight. I want to take about 5/10 off this area in here, which will get me down to what the nominal size of the original shaft is. And I think it's going to help me out as far as not being too tight on the bearings and my piece sliding in here like it should. So I'm just going to very carefully, I'm probably going to do this in 2 passes. I know it's not a lot of material, but I'm worried about chatter. So I'm probably going to do maybe 3/10 and then come in here and clean up with a 2/10 pass. Just to be on the safe side. So I got this now all back to nominal size. I think we're in good shape. It's interesting though, and I got to measuring it more after I'm in here, but this stock that I've got, like I said, it's just cold rolled steel, but there's about 4 or 5 thou difference in diameter depending on where you measure across the shaft. It took a full 5 thou cleanup on the front end, but as it got back here, it was just barely even fuzzing it. So it's interesting, but my measurements are measuring the right diameter to where I know I'm not cutting a taper. So it's just the stock, it's just the material, but we're good. I think what I'm gonna do now is we're gonna flip this over. We basically got to do the same process on the other side. I'm not gonna bore you with all that. I'm just gonna knock it out, and then we can get ready to start cutting some keyways on the shaft. Got all my lathe work done now. All my bearing journals are to size. The ends where the pulleys slide over are to size. And I came over here, did it off camera, but I actually tightened down the bearings, made sure I could turn the shaft. I made sure I could slide the pulleys up on each end. Everything is a good fit. So the final step in making this new shaft is we've got, again, the 3 keyways in here. One here, one here, one here. These 2 are for the tight pulleys that will actually rotate the shaft. And then this one here is for this, there's a little linkage that slides on a key here that engages a gear. So this little gear fits in that dog, and there's again a little piece that slides this in and out that engages and disengages that gear on the shaft. That's basically turn the machine on and off. So anyway, we've got everything ready to go over here. The keyways on this are a little bit odd. We ran into this when we made a previous shaft on this machine. The width of these keyways are 21/64 of an inch, which of course I don't have an end mill that size. That's a very unusual size, but back in the 1890s, for some reason, they use these unusual sizes. What we will do is I'll go down to the next size smaller than that. We'll cut it in here, and then we'll basically just move the table left and right or in and out or what have you to get it to the right width and make sure all of our keyways fit through here. So let's go get the milling machine set up. We'll get this shaft up on there. I've got basically the extents that the keys need to be cut, and the depth of them is, they're all 150 thou deep. Again, these keys actually are rectangular in shape too. They're not even square. Really oddball, but that's the way it is. I've got my shaft clamped down to the table, and I've showed this trick before, but instead of trying to put it in a vise and all that, I just pull the vise off and we just lay it on top of some of these ways. These are not ways, but T-slots. These T-slots are actually milled perpendicular to the table, so you can lay a shaft on here and you've got it perpendicular. You don't have to bump it around and all that kind of stuff. Just something that saves a few minutes. Some people don't like doing it because they don't like to take their vise off once they get it trammed in. I can tram a vise in quicker than I can tram that shaft in, so we're going with it. Next thing I got is a edge finder in here, and what I want to do is find the edge on both of these. I use my digital readout. I'll zero it on one side, go to the other side, find the edge again, and then come up and I'll take half of that distance, and that will put it right smack dab in the center of the shaft. So let's fire the mill up. And the way that works is when I feed it in, and that bottom part is kind of spring-loaded in there. When it jumps over, it is perpendicular right there. So I zero my digital readout. I'm going to do it again just to double check my number. I'm on zero again, so we're good. Yep, we're good. So now what I'll do is I'll come up, come to the other side. Same process. Pull it in until it jumps over. Going real slow here. Here we go. I'm showing you my digital readout. I've got some glare on there from the lights. I'm sorry about that, but you can see here in the y-axis, that's our distance that we moved over there. 1.9404. I want to take half of that, so let me raise my part up off the mill where it's not going to bump it. And what I'm going to do is there's a half function on here right here, so I'm going to hit the half function. It's going to tell me to select the axis that I want, which is the y. And what it did is it divided that number in half. And what I do now is I just take my table until that reads 0. This is measurements in thousandths of an inch, or actually 10,000ths of an inch, out to 4 places. Got talking and lost my direction there. All right, let me get it down to 0. I'm within 2/10. I'm just going to zero it right there. And that now is on the center of that shaft. Just quick and easy little operation there. I've got a 5/16 inch end mill in here, which is just 1/64 of an inch smaller than what we need. So doing the math, I'm going to be able to make this trench, and then I need to move my table 8/1000ths in and out both directions, and that will get me on size, or should get me pretty close. And we got the piece here that we can do a test fit with. So we'll fire this thing up. What I'm going to start by doing is just bringing the table up until that end mill is cutting all the way around, because I made a measurement across the flats. So I need to zero it when it's cutting basically right flush, which is right there, with both sides. So I got that zeroed out now. And I need to go 150 thousandths deep. So I'm just going to go ahead and start by going to one end of my travel. And we'll probably plunge down about 50 thou. I don't know, maybe 25. We'll see. I think I'll do 50. This is a center cutting end mill, so I should not be leaving a hollow spot in the middle. All right, we're just going to take it to the other side. All right, we're going to take it down another 50. Cut back to the other side again. Feeding this by hand. All right, we'll go down another 50. That'll get us to 150 deep. And back across we go. All right, so now I need to go my 8th thou, and I'll just use a digital readout, and we'll come 8 thousandths toward me. 3, 4, 5, 6, 8 thou right there. I'm gonna zoom down that back side. Go all the way to the end, right there. Now we'll take it 8 thou off of center, coming back the other direction. 3, about right there. All right, I'm gonna raise my cutter up. There's a little bit of burr on there, but that is pretty darn close. I've got a little Noga deburring tool that's made for doing keyways. You don't want to push down too much on this or it'll really dig in, but still got a little burr on the ends, but sides feel real good, so that feels good. And I'll take a file or something and knock those. For these little round ends, I'll just use another Noga deburring tool here that I've got. Yeah, that's going to go down just fine. All right, one down. We're going to move the shaft down and get the next one in position to cut. Same process. We're ready to start putting this shaft back together, getting ready to go back on the machine. And the first thing I'm going to do is there was a collar that's on here. You can see where it was on the other shaft. That basically is just a stop collar to keep the shaft from moving side to side in these plain bearings. So we will slide that up on there, and I'm going to get a measurement down here as to where that should be. And let's see what that is. That's about 19 7/8 it looks like, which is about right there. And we'll put a set screw in here to lock that in place. Now, I was going to replace this set screw with a socket set screw, just because I don't like something protruding like that on a rotating shaft. It's something that can catch on something. You know, back when this was built, that was pretty much what they had to work with. Problem is that when I went over there and grabbed a set screw to go down in that hole, I couldn't find one that fit, and I'm scratching my head, then it hit me. The threads on this is 1/2" 12, and that's a pretty common thing on old machines. A 1/2" bolt or threads in today's world is 1/2" 13 threads per inch. This is 1/2" 12 threads per inch. So pretty much stuck with that one because I'm not going to find a 1/2" 12 socket cap screw unless I make one myself, which I'm not interested in doing. So that goes on there. We put the bearing cap on top of here. I'm going to get a little bit of oil and put in that journal. I'll just put a little bit on here to get started with. And we've got our bolts here to go down on this. right, that is clamped down, and you can see my bearing is turning nice and free. And I made special care when we did that to get it just right. All right, next thing up is we've got basically a gear that goes on here, and then there's this little piece that slides back and forth. This piece is keyed, and it slides on this keyway. There's a slot in here, and basically this moves in and out as needed to engage and disengage. And when you engage it, it locks together. When you disengage it, it pulls it out. And this is just free spinning on the shaft when it's pulled out. So let's go ahead and just make sure, yeah, that's good clearance there. We'll go ahead and tap this down in place. Take my hammer. And we'll slide this up on the shaft. And that slides back and forth. A little bit tight on the back side. Let me see if I can tap that down a little bit more. Yeah. So again, this just moves back and forth a little bit. So that just moves back and forth about that much right there to disengage and engage on this gear. We'll slide this up on. And of course, when the shaft is turning, this is keyed, so it's always moving. When the machine is disengaged, this gear is not going to spin, and when you slide this over, it engages. Now you're turning all the gears up inside the machine. So that's how this little mechanism works right here. Next, we'll put our bearing cap on here, a little bit of oil. There we go. Both our bearings are in place. Gear is good. This piece here, see it has a slot in it as well. It just slides up on this end. As far as I can tell, it's not engaging or disengaging anything. I think it's just to give some balance to support that rod that goes back and forth in here to adjust this. So all this is pretty much now ready to go back on the planer. I do have my pulleys to put on each end, but I'm going to wait until I get it on the machine to put the pulleys on. But the assembly is ready to go back on like it is right now. What I can do is go ahead and get my adjusting rod here. This is what engages in here on the two dogs. And start, this is the dog down here that fits over this piece to, is that right? No. All right, I will go ahead and assemble my my little dog pieces. This piece here fits down in that groove. This bar, it's actually on the bottom side of this. I'm going to flip this bearing over. If you look, there's a area here that this bar slides in. There's one on the other side too. That's the guide for it. But I'm going to assemble it this way. So this one goes on this end. And we've got this one that goes on here. I can fine tune the distance, but that's pretty close. I can see from the marks in the bar where the set screws were tightened up. Engage that, and that's what moves my pieces back and forth. And then on the end down here, this piece here that goes up to a linkage, I'm gonna wait and put that on later just so I can slide it in and out. That's pretty much it. I think we're ready to put this on the machine now. one new shaft, all ready to go, all reassembled, all nice and smooth. Definitely a nice replacement for this one here that was just really had too much wear and pitting in it to be of any use. And like I said, this is ready to go back on the planer. I'm going to do another video to do the installation of these last two shafts and some other components in there. I'm really just running out of time, as well as hitting a deadline for getting a video out for you guys. So I'm just going to go ahead and we're going to call this video a wrap and come back in later and do the installation. Like I said, we'll install the pulleys once we get it on the machine. And with that, I think we're pretty much done with what we can do today. So anyway, as always, thanks for watching, guys. And please subscribe to the channel if you haven't already. Please leave comments. They're always appreciated. And thumbs up if you like what you see. And we'll catch you on the next video.